Hello, so today we are going to practice circles. We are going to do SAT questions of circles. The first one, what is the area of a circle whose circumference is 2 pi? This is simple. Circumference is 2 pi r, that is equal to 12 pi here. So pi and pi will be cancelled. This will be cancelled 6 times. Now area of circles in terms of pi. Area is equals to pi into radius square. Radius is coming as 6. So this would be pi into 6 square, that is 36. So the answer should be 36 pi. Now second question, what is the diameter of a circle whose area is 4? So area is again pi into radius square. So radius square is going to be area, that is 4 divided by pi. So radius is coming as under root 4 upon pi. Now we'll just split the under root, root 4 upon root pi. Root 4 is 2 upon pi. We have the radius. Now diameter. Diameter of a circle is twice the radius. Diameter is equals to 2 times the radius. That is equal to 2 times 2 upon pi. That is 4 upon, this is a root here. That is 4 upon root pi. So 4 upon root pi. This is the answer. Now, what is the area of the shaded region? So we have to find the area of this region. For this, first we'll find the inner piece area. Now for this we know the formula, that is theta upon 360 multiplied by total area, that is equal to pi r square. We get this by unitary method. 360 degree represent the whole circle's angle, that is equal to pi r square. So 1 degree will be equal to pi r square upon 360. Same way theta degree is theta upon 360 multiplied by pi r square. So this area is 60 upon 360 multiplied by pi into radius square. Let's just write it r square for now. We'll convert this later. So we are going to get 1 upon 6 pi r square. Now the shaded portion area, total area of a circle is pi r square. From here we subtract 1 upon 6 pi r square. We can take pi r square common. We'll get 1 minus 1 upon 6. So that should be 5 upon 6. Now we can put the value, pi will remain as pi only. Otherwise it's 22 by 7. But the options are in terms of pi only. Into r square. That is 12. So 12 square multiplied by 5 upon 6. We'll cancel this 2 times. This is going to be 10 multiplied by 12. That is 120 pi. So this is going to be the answer, 120 pi. Now the next question. Just a minute. Now in this question, the inner circle is tangent to the outer circle at a point P. Point O is the center of the outer circle and OP is the diameter of the inner circle. What is the ratio of their areas? So OP is the diameter. So for the inner circle area, we can take this as R. If this is R, this is also R, because this is the diameter of the inner circle. But for the outer circle, O is the center of the circle. So radius of the outer circle, let's say that is capital R, equals to R plus R, that is 2R. Then this is the tangent. The inner circle is the tangent to the outer circle. That means it touches it at only one point at right angle. But really this all doesn't matter. What is the ratio of the area of the outer circle to the area of inner circle? We already have that figured out. We know the ratio of the radius. So area of the outer circle upon area of the inner circle will be equal to pi into capital R square, that is 2R whole square, upon pi into small r square. This pi and pi will be cancelled. 2r whole square is 4r square upon r square. These will be cancelled. So the ratio is 4:1. This is the answer. D option is correct. 4:1. Now fifth question. The ratio of the area of a sector to the area of a circle is 3:5. What is the ratio of the length of the arc in the sector to the circumference of the circle? Okay, first of all, their ratio is given as 3:5. We have to figure out their angle basically. If we can figure out their angle, we can figure out the ratio of arc and circumference also. So, area of this sector upon area of this circle, that is pi r square, is equals to 3:5. So we can say that area of this is equal to 3/5 pi r square, and it's supposed to be theta upon 360 into pi r square. So from here we can compare. Theta upon 360 is equals to 3/5. We even don't need to find theta. If you want, you can, but we don't require to, because now we can find the arc. Arc is going to be theta upon 360 into circumference, that is 2 pi r. If theta upon 360 is 3/5, we can just put it here. 3/5 multiplied by 2 pi r. This is the arc. And if you want the ratio arc upon circumference, so that should be equal to arc upon circumference, that is 2 pi r. These are cancelled. So the ratio is again coming as 3:5. This will be the answer. Let's continue some more questions. Alright, so here we go. What is the area of the circle O if the length of the arc AP, PQR, this is the arc. The length of this arc is 8 pi. So the length of this arc, we just did the formula theta upon 360 into circumference. So theta, that is 120 degree divided by 360 degree multiplied by circumference, that is 2 pi r. This is coming as 8 pi. Alright, so we can just cancel it. 360 can be directly divided by 120. These will be cancelled. This will go 3 times. And this 2 pi can be cancelled from here. This should come as 4. Pi and pi will be cancelled. 8 upon 2 is 4. So basically what we are getting is 4 is equal to, only r is left here, upon 3. So therefore r is equal to 4 into 3, that is 12. So radius is coming as 12. So what is the area? Area is equals to pi r square. Pi is still in the question. We won't put the value into 12 square. That is 144. So E option is correct. 144 pi. Now the 7th question. The area of the circle below is 81 pi. What is the length of BA? We have to find the length of only BA. Okay. The area is given. We can figure out the radius first of all. So the radius will be pi into r square equals to 81 pi. Pi and pi are cancelled. So r square is coming as 81. So r is under root 81. So r is equal to 9 centimeter or 9 units, whatever. So radius is 9. So now this is important. Any line going from the center to circumference is basically its radius. So this is going to be the radius. And this O is also going to be the radius. So this is 9, this is 9. And this is 60 degree, this is 30 degree. So this is going to come as 90 degree. Okay? Because 30, 60 and this is 180 minus 30 minus 60, that is basically 90. Now from this we can use trigonometry to find these values, because Pythagoras theorem is not going to work as much, because we have two missing terms. We don't know the value of BO, we don't know the value of BC also. So we can use trigonometry. Say we use this angle, that is 30 degree. And we can't use 10, because here we have base and perpendicular, both are missing. We have the hypotenuse, so we can use sine and cos. Say we take sine 30 degree. That should be equal to Perpendicular upon hypotenuse. Hypotenuse is decided. It's opposite to this 90 degree. That is equal to 9. And perpendicular is opposite to the angle. We are taking this angle C. So opposite to we have OB. So OB upon 9 is equals to sine 30. Sine 30 in trigonometric table is 1 by 2. 1 by 2 is equals to OB upon 9. So therefore OB is equals to 9 by 2. That is equal to 4.5. So OB is coming as 4.5. Now this whole thing is 9. If this is 4.5, what is the remaining part? AB is equal to 9 minus 4.5. So 9 minus 4.5 is also 4.5. So AB is coming as 4.5. A option is correct. Now the next question. The area of the triangle ABC is 18. What is the area of the shaded region? So for finding the area of the shaded region, we have to find this whole area. This should be theta upon 360 multiplied by area of the circle. So theta, that is 90 degree, divided by 360 multiplied by pi into radius square. Now, one problem we face is we don't know the radius, but we can figure that out because this and this are going to be the radius. BC and BA both are radius. And this is a right angle triangle. So in a right angle triangle, if we take one side as base, other will be as height. So area of a right angle triangle is half into base into height. So half into, if we take this BC as base, then this BA will be height, is equals to 18. So we are getting r square equals to 18 into 2. This 2 is divided here. It would be multiplied on the other side. So r square is coming as 36. Radius is equal to 6. So by this we can find this 90 upon 360, that is 1 by 4 pi into 6 square. So area of the circle is 1 by 4 pi into 36. So this will be cancelled 9 times. Area is coming as 9 pi. Now area of the shaded portion is basically area of this whole thing minus area of this triangle. So 9 pi minus area of this triangle, that is 18. So 9 pi minus 18. This is the answer. Let's try this question also. The point O is the center of the circle. See, this is the figure. What is the area of the shaded region? Now O is the center of the circle for both of them. So this radius is 6. And this whole radius, let's say this is capital R, is equals to 6 plus 4, that is 10. Now if you want to find the area of this shaded region, this should be area of the bigger circle, semicircle, minus area of the smaller semicircle. Let's say this area is A1. So A1 is equals to, I'll just change the pen color, pi into capital R square, that is 100. And we are talking about semicircle first. So half pi R square minus area of this semicircle, that is half pi into 6 square. You can take half pi common. We are left with 100 minus 36, that is 64. So area of this above shaded portion is 32 pi. And this is simple. This is just the semicircle. Let's say this is A2. So area of the semicircle is half pi into radius square, that is 36. 6 square is 36. So this is coming as 18 pi. Now the total area will be the sum of both of them. That would